Welcome to the DAK Machine Safety Podcast. We support the development of a safer, sustainable workplace. This podcast episode will explore guarding versus LOTO. These two issues continue to be on OSHA's top 10 list of alleged violations of safety regulations. Without a deeper understanding of the design intent for these means of safeguarding employees, safety professionals and engineers cannot properly design engineered safety controls and procedures for employee protection.
I have never heard of the term design intent regarding employee safeguards. What do you mean by design intent?
Safety professionals and engineers must understand the difference between guarding for normal production and providing safeguarding when an authorized worker enters a zone of danger or hazard area to perform necessary work. The design intent for normal production is to prevent inadvertent exposure to hazards. The design intent for an authorized worker who intentionally enters a zone of danger must protect the worker while they perform their work.
What is required for normal production?
Under OSHA, guarding during normal production is regulated by 29 CFR 1910-212. In this situation, you design and implement guards and engineered devices to protect a worker from inadvertent exposure to a hazard, defined by the online Cambridge Dictionary as not intentional.
I thought guards were supposed to prevent access to hazards.
Remember the last episode in the myth that all guards are supposed to prevent access. It is not true.
Can you provide a credible basis for the assertion that guards do not prevent access?
Yes, this issue is sufficiently important to be repeated. OSHA publication 3070 Safeguarding Equipment and Protecting Employees from Amputations clearly states that machine guarding prevents inadvertent access to a hazardous machine area. It mentions the term inadvertent 22 times.
Help me better understand the design intent for an authorized worker entering a zone of danger.
In this case, access is intentional in performing necessary work. Whether clearing jams, doing quality checks, or any one of many different service and maintenance tasks, guarding and safeguarding devices used during normal production must be suspended or bypassed to allow access. Remember that operational excellence aims to improve quality in production because those efforts will reduce the frequency of workers entering a zone of danger when problems occur.
But what if the worker is injured?
Good question. In such a case, it is usually not a result of faulty guarding. Remember that the worker intentionally suspends or bypasses those physical barriers, interlocks, or other engineered devices to gain access. Without access, the job cannot be done. Remember the analogy to your mechanic having to work on your car engine.
Yes, but please explain further.
If you designed an automobile hood to prevent access, you might bolt it down or interlock it so the engine would not run if the hood were open. Either way, the mechanic must unbolt the hood and bypass the interlock. It's impossible to troubleshoot a problem without the engine running, and it would be infeasible at best to try to set timing without power.
Okay, I think I understand. How can I protect a machine when an authorized worker enters to do an assigned task?
Let's start with OSHA. The OSHA regulation for this situation is no longer 29 CFR 1910 21229 CFR 1910-147. The control of hazardous energy became effective in 1990. Lockout-tagout is in parentheses of the regulation's title for a good reason. The regulation deals with the control of hazardous energy, and locking or tagging a primary energy source is merely how a worker can ensure that the machine will not restart unexpectedly while they are in a zone of danger. Referring only to lockout-tagout merely confuses things when we encounter situations where energy is required or the hazardous energy is controlled by engineered devices that prevent unexpected energization.
Can you explain further?
Sure. Lockout-tagout suggests isolating and locking a primary energy source to control hazardous energy, but not all energy is hazardous.
It's still unclear to me that not all energy is hazardous. Please explain further.
Yes, and please pay close attention because this is important. With the publication of American National Standard B11 2023, we now have definitions for three different types of energy. Beneficial energy, energy that is required or essential to reduce risk to personnel when performing a task. Hazardous energy, any energy that could cause harm to personnel. Non-hazardous energy, energy that does not expose personnel to harm when performing a task.
Gosh, this gets more and more complicated.
We apologize, but this podcast series merely reflects the reality facing today's workers. B11 is a risk assessment and risk reduction methodology that provides management and safety professionals with the tools to implement feasible risk reduction measures for recognized hazards.
How does it do that?
B11 reflects the workplace reality that mechanics and maintenance personnel have long recognized. Decades of performing task-based risk assessments provided the voice of the factory floor, and this most recent update of B11 reflects the reality your workers already face. Hazard identification must distinguish between hazardous energy, non-hazardous energy, and beneficial energy.
What's an example of beneficial energy?
Consider the commercial showing a vehicle's body welded in an automated body shop. Those overhead robots must typically be held in place by some form of energy when skilled workers enter to perform maintenance tasks. Coil winders in the metal forming industry require power to keep a steel roll safely coiled. Removing the energy would create hazards and risks.
What is hazardous energy?
Many safety professionals and engineers have considered all energy to be hazardous. Repeating for emphasis, this is not true. Hazardous energy is energy that could cause harm to personnel performing specific service and maintenance tasks. Hazardous energy could result in cuts and crushing injuries, and is often involved with serious and fatal injuries.
Okay, what was the third form of energy?
Non-hazardous energy does not expose personnel to harm when performing a specific task. An example is a simple one-robot cell, where a robot grips a part as part of normal production. If a task requires entry, but the simple fact of the robot gripping a part does not create a hazard for the task being performed, that is non-hazardous or beneficial energy.
Does 29 CFR 1910-147 address the different scenarios my workers will face?
Somewhat. The regulation addresses tasks considered minor servicing, and that power will be required for testing and positioning once a service and maintenance task is completed under lockout-tagout.
Doesn't that cover everything?
No. That's why you are in the early stages of learning about alternative methods. OSHA and the OSHRC Review Commission have ruled that setting up a machine is service and maintenance that must be done under lockout. Attempts to use the minor servicing exemption to 29 CFR 1910-147 failed to persuade the OSHA Review Commission.
Could you please provide more information about this minor servicing exemption to help me better understand it?
Sure, it's best if I read the exact 29 CFR 1910-147 regulations to assure accuracy and context. Control of hazardous energy is required when an employee is required to place any part of his or her body into an area on a machine or a piece of equipment where work is actually performed upon the material being processed, point of operation, or where an associated danger zone exists during a machine operating cycle. That is addressed in 1910-147, a 22B.
What does the exception state?
The exception to paragraph A22 covers minor tool changes and adjustments and other minor servicing activities which take place during normal production operations are not covered by this standard if they are routine, repetitive, and integral to the use of the equipment for production, provided that the work is performed using alternative measures which provide effective protection.
If my workers have a task that does not qualify for the minor servicing exemption and is not testing or positioning, it would be considered service and maintenance requiring lockout. Is that correct?
From OSHA's perspective, yes. The dilemma is when those tasks require power. That's where alternative methods come in. It does seem complicated, but we didn't create the laws and regulations, nor the real world of maintenance tasks. We're offering a legitimate path to doing such tasks with acceptable risk and being able to win before the OSHA Review Commission, should it come to that.
Why do you say the OSHA Review Commission will accept an alternative method?
Excellent question. Before dealing with OSHA, you must convince your management and legal staff that your actions are both legal and safe. We fully concur with that line of questioning. Thanks for tuning into this episode by DAK Machine Safety. Today we discussed guarding versus LOTO. In the following podcast, we'll address controlling hazardous energy and will supply the answers to the questions you must answer. You can support us by clicking like and subscribing. Take care, everyone, and until next time.